Electron dot notation. The electron dot notation, and my clicker's not clicking. Yeah. Here we go. Our learning target. We've been talking about success criteria with the I can statements here, but what is the overall target? Okay, what's the overall target that the state of Ohio says? I can identify the type of chemical bonding that has occurred in a given compound. Now, we're going to go over several different days worth of this learning target. Okay, so this just falls into, this electron dot notation just falls into this learning target. Now, let's see how we did when we wrote down the I cans in our notes. Okay, because that's my success criteria here. I can what? I can predict the possible interactions between atoms based on their valence electrons. There we go. That was the one Nick brought up, wasn't it? Valence electrons. The second one that I have, the second I can, was I can construct the electron dot diagrams of main group elements. We hit that one too, didn't we? Now, what is a main group element again? That's from last unit, the periodic table. What's a main group element? The S and the P block. Excellent. Okay. The S and the P block are the main group elements. So we're going to deal with writing electron dot notations of the main group elements. Now, valence electrons. What is a valence electron? That is an electron that is on the outermost energy level. We talked about the atomic theory, and we talked about Bohr and Schrodinger, and about how we have orbitals. Well, the outermost orbital, the outermost electron shell is the valence electrons. So, as I'm looking at this two-dimensional drawing, I have the nucleus right here. Okay? I have blue and I have yellow, which means protons and neutrons. I have these red spheres on the outside. Here's the first energy level. The green one's the second energy level. The blue one's the third. What is my outside energy level? Blue. Excellent. How many? Count around the horn. How many electrons are on that outermost energy level? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. 8 sound right? So, knowing what we know about electron dot notation, electron configuration, what has 8 valence electrons on the third energy level? What element? Go ahead and take out your periodic tables. We're going to need those anyway. Yeah, Nick? Argon, right? So we're predicting just on our electrons that this diagram up here is argon. 8 valence electrons. So the valence level, once again, is the outermost energy level. Now, let's look at oxygen. You should be able to construct an electron electron configuration for oxygen. So go ahead and write oxygen and its electron configuration in your notes, and we'll see how you do. That's last chapter, folks. Last chapter. So go ahead and write that down. We'll see how we do. Did you write down 1s2, 2s2, 2p4? Hopefully you did, because that's the electron configuration of oxygen. Now, what is our outermost energy level here, folks? Okay, not the sublevel, just the outer level, which is number The level. Just the second, right? The second energy level. We only have two energy levels here. Here's energy level 1. Here's energy level 2. Now, the second energy level is the valence, the outermost. How many electrons do I have on my outermost level? What's this? Is this on the outermost level? Yeah, it's on 2, right? So there's 2, and here's 4. Is that on the outermost level? Yeah, so how many total? 6. 6 valence electrons, right? Calcium. Go ahead and write calcium's electron configuration down, and we'll talk about it here in a second. Ladies and gentlemen, for calcium, did you have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2? Hopefully, once again, you did, because that is the correct electron configuration for calcium. Now, let me ask you this. Dalen, let me ask you this. What is my outermost energy level? The 4th energy level. Now, how many electrons, Carly, how many electrons are on that 4th energy level? 2. So I have 2 valence electrons. Now, let's look at our periodic tables. All right, find calcium on your periodic table. Isn't calcium all in the family of the alkaline earth metals? Okay. What's going to be the valence electron for that, the valence electrons for that entire family? 2. What about the alkali earth, or excuse me, the alkali metals, their next door neighbor? How many valence electrons? Yeah, 1. Okay. Skip on over to group number 13, because that's our next main group element. How many valence electrons in group 13? 3. Skip to the halogens, group 17. How many valence electrons in group 17? 7. All right? So our periodic table tells us valence electrons, right? Right? Here's a trick one. How many valence electrons does helium have? How many? You're going to say 8. You're going to say 8 because what family it's in, right? How many electrons does helium have total? It only has 2, doesn't it? So how many valence electrons does helium have? 2. So remember that. Remember that. Even though it's with the noble gases that all have 8 valence electrons, helium's only got 2. So remember that. That's one you just have to commit to memory. Now, we talked about calcium here. We talked about 2 valence electrons, right? Let's talk about now how we're going to do this dot notation. So what I have up here, XY. And this XY right here in the middle is just symbolizing the symbol, I guess. It's just the symbol of an element. We don't have an XY on our periodic table, so it's a random, it's a made up. Now, the dot pattern that we follow is 1, 2, 3, 4, 5, 6, 7, 8. In that particular order. 1, 2, both to the right. 3 up top, 4 to the left, 5 to the bottom. 6 up top, 7 to the left, 8 to the bottom. Now, why do we do it in that particular order? Well, they represent the s orbital on the right there. Px, Py, and Pz. So this represents the s and the p orbitals, which are our main group elements. Now, didn't we talk when we did the electron configuration? Didn't we talk about filling one electron on a p orbital before you doubled it up? So we had one on the px, one on the py, one on the pz before we put two of them on there, correct? That is why that we go the order that we go into, so that we have one electron represented in the px, the py, and the pz before we double them up. Now, once again, our dot pattern. Those are the two s's, right? Those are the two s's. Here's a px, here's a py, here's a pz. There's the second px, there's the second py, and finally the second pz. So there is a rhyme, there is a reason to why we use this numbering system. Now, the very easiest electron dot notation to make. Why? Well, I know that hydrogen has the electron configuration of 1s1. So how many valence electrons does hydrogen have? 1. So here's my hydrogen, there's my symbol, and I'm going to put a dot in the 1 spot. Ladies and gentlemen, the electron dot notation of hydrogen, right here. That easy. Beryllium. Let's find beryllium on our periodic table. Find beryllium. What's the atomic number of beryllium? What is it? 4, right? It's 4. So beryllium, does beryllium have 4 valence electrons? No, because they're not all on the valence level. If I write out the configuration, beryllium's 1s2, 2s2. What's my outermost energy level? The second energy level. So how many electrons do I have on that outermost energy level? 2. So I write beryllium. And then I add dots to the 1 spot, to the 2 spot. Ladies and gentlemen, there is the electron dot notation for beryllium. Sulfur. Let's get a little more complicated. A little more complicated. Go ahead and write electron configuration for sulfur. For sulfur, we should have 1s2, 2s2, 2p6, 3s2, 3p6. So, as I'm looking here at my electron configuration, right here, what is my outermost energy level? Savannah, what's my outermost energy level? Okay, what is my outer level? It would be 3. Now, how many electrons are on 3 here? 6, right? Can we all agree with that? So, when I do my electron dot notation, I have my S, and I'm going to add electrons in a specific order. I'm going to fill 1 and 2. Where do I go next? Up top to 3, then to 4. Here's 5. Ladies and gentlemen, there is 6 valence electrons for sulfur. So this is my electron configuration for sulfur. Krypton. krypton. Now, let me ask you this. Do we need to write the electron configuration to do this? We do not. How many valence electrons does krypton have? 8, right? How can we tell that? Because it's in group 18, all of which have 8 valence electrons except helium. Good. So, here's my electron dot notation. Now, look at this, what I have in red here. Look at this that I have in red here. When I follow the electron dot notation, I have orbitals crossing there, right? I have different orbitals crossing. My d orbital is, or sublevel, my d sublevel is crossing with my s sublevel. How many valence electrons are there? Okay, how many? We looked on our periodic table, we said 8. So 2 from the S and 6 from the P. Remember, we're only dealing with main group elements when we're writing these electron dot notations. So how many dots am I going to have around krypton? 8. So it's going to be filled, right? It's going to be filled. Krypton, boom, boom. There's my S's. PX, PY, PZ. PX, PY, and PZ. So this is the representation of krypton, which has a filled outermost energy level of 8. All right. Now we're going to talk about something later on that's called the octet rule. Okay, what do you think that is dealing with? What's oct? 8, right? So it's going to be dealing with something about 8. Now, let's talk about ions. Okay? Remember in the video before where we had little anion? She was negative. And we had cation, which was positive. Okay, we're going to talk about some ions here. Now, I have written up there the electron dot notation of chlorine, right? How many electrons is chlorine away from filling its outermost shell? 1, right? It's in group 17. Full shells are in group 18. So it's 1 electron away. Does it make sense for chlorine to gain 1 electron to fill that outer shell? Absolutely. So what we have is there's that 1 electron for chlorine to fill that outer shell. But when it does so, we draw these brackets and say, okay, we have 1 extra electron. So this charge that chlorine has right there is a -1. Why? Because how many protons does chlorine have? 17. It gained 1 electron, so how many electrons does it have? 18. 18 minuses, 17 pluses. What's my net charge? -1. Now, let's look at sodium. Right here is sodium. Sodium's an alkali metal. Sodium's an alkali metal. We learned the other day that metals like to lose electrons, right? Sodium has 11 electrons. If it loses 1 electron, it fills its outer level with 10, right? It's like taking away that entire 3rd energy level. So, what happens with sodium? Well, it wants to get rid of that electron. Boom, there it goes. It's gone. See, there it is. Oop, it's gone. So now, sodium has 11 protons. How many electrons? 10. 11 pluses, 10 minuses. What's my net charge? 1 plus. So sodium here has a 1 plus charge, the sodium ion. So those cations and anions that I introduced to you last chapter, last unit, are dealing with gaining and losing electrons. Okay? Now, how would I represent my electron dot notation for sodium? I could do this. I could have sodium like this and have my brackets, and I could have that plus charge. So I could write it like this right here with nothing around it, or I could also write it with this with 8 around it. Either or. Okay? 6 of one, half dozen of the other. What's that mean? It's the same. Okay? It's the same. Isn't a half dozen the same as 6? Okay? Just another way to write it and to say it. Okay? Now, I believe that's the last slide. What I have for you, what you need to do with the remainder of the period. Number 1. Okay, hold up here. I'm going to explain it first. I'm going to give you a piece of paper where you're going to write down either the learning target or the success criteria or the I can. When you're done with that, you're going to bring it up here, put it in a box, and you're going to grab a Chromebook. Why? Because this electron dot notation practice is on the Google Classroom. So you're just going to click that, and it gives you, I think, 20 elements that you're going to write the electron dot notation for tomorrow. And just write it in your notes somewhere. Okay?